Say after that in text, there is the topic thermodynamic state variables and equation of state. So simply we can say the thermodynamic state variables are nothing but pressure, volume, temperature, internal energy like this. Thermodynamic state variables means all those variables or the physical quantities with the help of which you can represent the thermodynamic state of the system. So that can be represented by pressure, volume, temperature, internal energy. So we can say all these are thermodynamic variables. Now these thermodynamic variables are of two types: extensive variables and intensive variables. Now extensive variables that indicates the size of the system, and intensive variables such as pressure and temperature that does not represent it. Okay. Now this is just information, so you have to remember this thing. Exam oriented આવું કંઈ important નથી. બરોબર છે, એટલે એની બહુ ચિંતા કરતા નહીં. Now the quasi-static process. Non-equilibrium states of a system are difficult to deal with. It is therefore convenient to imagine an idealized process in which at every stage the system is an equilibrium state. Such a process in principle infinitely slow, hence name quasi-static, meaning nearly static one. Okay, or steady one we can say. So in each and every state we can say it is in equilibrium. So that type of process in which this happens, that is called quasi-static process. Now there are different types of thermodynamic processes, so we have to discuss all these. First, now take isothermal process. Isothermal process means the thermodynamic process in which the temperature of the system that remains constant. Temperature of the system that remains constant. Now, for isothermal process, let's derive the equation for work done. See, our generalized equation for work done, that is integration V1 to V2 P dV. So we can write W, that is equal to, now P is replaced by mu RT by V as per the state equation PV equal to mu RT. So W equal to integration V1 to V2 mu RT by V dV. Now mu is constant, R is constant, and for isothermal process temperature is also constant. So W, that is equal to mu RT integration V1 to V2 1 upon V dV. But integration 1 upon V dV, that is ln V. Now take the limits V1 and V2. So we can write now W equal to mu RT. First V equal to V2, the upper limit, then minus V equal to V1, lower limit. So resultantly W, that is mu RT ln V2 minus ln V1. So we can write W, that is mu RT ln V2 by V1. So this one is the equation for work done in isothermal process. Now see here, when we think about the isothermal process, then delta U, change in internal energy, that is 0, because change in internal energy that depends on the change in temperature, but here the temperature is constant one. Okay. Internal energy depends only on the initial and final thermodynamic state. આપણે આગળ ડિસ્કસ કર્યું હતું કે કયા રસ્તે સિસ્ટમ ઇનિશિયલ ટુ ફાઇનલ જાય છે, ઇટ ઇઝ ઇમટીરિયલ. એ ઇનિશિયલ અને ફાઇનલ આ સ્ટેજ ઉપર જ એ ડિપેન્ડ થાય છે. તો ટેમ્પરેચર ઇઝ કોન્સ્ટન્ટ, મતલબ કે ઇનિશિયલ થર્મોડાયનેમિક સ્ટેટ અને ફાઇનલ થર્મોડાયનેમિક સ્ટેટ બંનેનું ટેમ્પરેચર સેમ છે. તો અને જો એ ટેમ્પરેચર ઉપર ડિપેન્ડ થતી હોય તો ચેન્જ ઇન ટેમ્પરેચર ઇઝ 0, સો ચેન્જ ઇન ઇન્ટરનલ એનર્જી that is 0. So simply we can write as per first law of thermodynamics, delta Q equal to delta U plus delta W. We can write when delta U equal to 0, delta Q that is delta W. So here net heat absorbed that is equal to work done. Now see, if V2 is greater than V1, so final volume is greater than initial volume, so that is called expansion. Here temperature is constant, so we say if V2 is greater than V1, then that is called isothermal expansion. In this case, your W that will be greater than 0 means work done, that is positive. And if work done is positive, then it is called work done by the system. It is called work done by the system. Okay. Now if V2 is less than V1, final volume is less than initial volume, so that is called isothermal compression. In this case, your W that will be negative, less than 0. So here work is done on the system. So you have to be careful. In MCQ or example, if these words are used, work done by the system and work done on the system, then you have to be very careful to take work done. You have to take it positive, negative as per this one. Clear to all of you?